Okay, heartily welcome to my little presentation. I would like to start with an expectation management. So this isn't anything real new. It is just an introduction. I started 6 months ago with that kind of topic and do not expect mind-blowing stuff yet. That I reserve for next time, probably at Hash Days 2013. And I somewhat sucks at presentations, so do not expect very clearly ordered slides or so. Just excuse myself. So yeah, we will just skip that. Yes, I work as a penetration tester, IT forensics, security specialist, got some certifications, degrees, and yes, I do some stuff. But the reason for this talk is the Berlin Sites talk of Felix Lindner, ethics, which he stated the wish that more people from the community would join this topic. And so I saw, yeah, why not? I already have some radio background, but just from the military side in Switzerland. So this would be fine to start with that topic. As usual, nights of research, I gathered about 3.6 gigabyte of public data. Speaking of videos, how to do things, frequency lists, everything publicly available. And yeah, I started just, so not yet fully there where I wanted to be, but let's fasten the seatbelts for a short trip to space. First, we will just talk a bit about what's this satellite topic all about. Then I will just only show us a few things about equipment. Then we will talk about satellite hackers and some future outlook. I did so for every piece of hardware I bought. Yes, please. Oh, yeah. Yeah, this had to do something with the resolution. I couldn't solve it before. But they're public even, so don't mind. Yeah, in the annex you find the hardware pieces described with the price tags as well and what they're capable of. This might be helpful if you want to start to dig into that as well. Yeah, I will skip some of the things here just because we're just running out of time otherwise. Interesting is that's a Latin word and it's Etruscan origin around 500 BC. The Etruscans invented the term bodyguard, and this is where satellite comes from originally. The orbit, yes, is the path around Earth. I will show you some of the orbits they exist, and you can have several payloads. That's the satellite function itself. Downlink, that is the communication from the satellite down. This is the interesting piece because sometimes there is interesting data transmitted there. And uplink even is more interesting because commands are sent up normally. And footprint, this is a term I need shortly to explain because satellite, especially DVB transmissions, are directed transmission to a certain region. And if you are in the best receiving region, then you can have a much smaller dish to receive the signal. The more far you are out of the center of the footprint, you need larger dishes. So this small dish is just a camping dish, and I blew it already up a bit because you need to target very precise with the small dish to get really a signal. But yeah. Launch, this is when the satellite is brought into orbit. Perhaps some of the people here already know the VSAT. There is even dish-to-dish communication possible for remote locations, for example. Then if you catch moving objects, even with radio transmissions, you need to correct for the Doppler shift. If the satellite is coming to you, towards you, then you need to get a higher frequency to get the signal correctly. And if it's going away from you, then you need to turn it down, the frequency. So this can be very challenging, especially thinking about a 7-minute time frame where the satellite is available. You need to do everything right, otherwise you will fail. And I failed a lot, you can't believe me. Then, yeah, we have things like biggest distance to Earth and smallest distance to Earth. We will come to that later on. And very interesting, we have these TTNCs, the telemetry, tracking and command centers. This is an example in Switzerland. Yeah, I will not talk too specific about that. This is a link in Wikipedia. This is related to some surveillance system in Switzerland, but it's public, so you can read it on Wikipedia. Very interesting. The first satellite was got up in orbit in 1957 by the Russian. They shocked the Americans because they were in competition which one was first in the orbit. Then we had several other satellites. The first geostationary, speaking, moving exact in the same speed like the Earth turns, so it stays always over the same location, was at 1963. And the first Swiss satellite is since 2009 in orbit. That's the Swiss Cube. It's also capable of ham amateur radio. And yes, you already heard about the Mir station probably, which was crashed in 2001. And now the IIS is another example of a very big object traveling through around the Earth. So yes, we have numbers, but yeah, I would say these numbers need to be watched very carefully because there might be some dark chiffres behind, because not every satellite which is launched in orbit will get into the statistics. Speaking of secret military projects and things like that. You also can have multiple payloads. Speaking, you have one launch with several satellites in it. And nowadays it's about 3,000 satellites are living. Also here the number, yeah, just it's an approximately number, not a correct one. What's very interesting, and this has much to do with security, the lifespan for a satellite can be up to 20 years. And if you calculate now the back from 2012, 20 years, did everybody implement encryption by 1992? I don't know. And also there are about 20 countries in space, and we have several launch sites. I will skip that because you can read that for yourself later on, offline probably. Interesting is that even Iran has now 2 satellites in orbit, as I heard. It's hardly to prove, but there might be some interesting things happen as well, also related to North Korea. But this is just, we don't talk about politics here. Rocket launch sites, normally I was thinking that around the equator would be best, but as you can see, even at the north and south regions, there exist launching sites where satellites are brought up into orbit with some rockets. Okay, talking about orbits, there are several different orbits existing. You have the low Earth orbit, which is just not so high. You have different moving speeds. And if you can estimate like 1 to 10 kilometers per second, the satellites are moving through space. It's hard to upgrade any encryption with that kind of moving object somehow. Just to illustrate it a bit, the low Earth orbit, then you have elliptic orbits, which also can be used for transfer. This is a transfer orbit for the geostationary part. And then you even have things like a graveyard. And yes, we probably also need to talk a bit about space debris later on. Okay. For real have a tracking of these satellites, you have to have a lot of different calculation possibilities. This broke my mind first. I missed too much classes probably in youth. So it's very hard to calculate that. But you can have this as a software tool already fixed for usage. And yeah, that's okay. Physics, yes. We won't go into detail, just good to know. If the object is near Earth in an elliptic orbit, it will move faster here because the gravitational force is much stronger the nearer the outer object is. And here at the apogee, the movement is relatively slow. And you have this gravitational force which pulls in direction to Earth, and you have the moving force from the centripetal, which from the moving around it. So they're somewhat not yet, not always really stable in the orbit. And this might also offer some possibilities to play around if you can change orbits, for example. We will see some of the possibilities later on. We have several types of satellites. Yeah, communication, navigation, GPS. Almost every smartphone has a GPS receiver in it. So also imagery. You can make very good pictures from outer space, from Earth, also for reconnaissance and espionage. What's very interesting is also there existing anti-satellite weapons, or killer satellites. And this is one example from Raytheon. It's just an object which is pushed into a satellite, physical force, that's all, kinetic force. And yeah, we will have a look what might happen if somebody really does that at a certain point. Then you have also special things like these teethal satellites, which have can be hundreds of meters in between the two elements. They even can turn for getting the right angles to measure things or to be away from other sensors which might influence another measurement or whatever. It's very delicate and complicated, the technology behind. Good. This is just an example from a satellite image, and yes, we are here in Lucerne. Just an example from the Topological Institute in Switzerland. Yeah. The satellite is also very complicated. You have thermal blankets like protecting the electronics inside. If the satellite is on the night side of the Earth, or especially out in space more, then it can be up to minus 120 degrees Celsius. And on the sun side, if it's real heavily shone on it, then it can be plus 120 degrees Celsius. And electronics need to function in that kind of environment, and this makes it kind of hard somehow. You have communication things, directional antennas, high gain antennas for getting signals up, getting signals down. You have tracking beacons, generally speaking, not necessarily in military satellites, I must admit. And you have things like star trackers, where the satellite has some device which is directed into the stars, and this device can estimate if the angle of the satellite is correct. And then they have momentum devices which can correct even physically the satellite's position, that he has the right position for sending, for example, DVB broadcast or something like that. If you get bigger objects, of course, it gets more complicated. I will not go through the details, but just to get an impression, a normal satellite might be just this big or even not that big, but the whole thing together is enormous complex. Good. Now we're talking shortly about dependencies. In finance sector, you have backup of transaction links for financial transactions. In communication, you have backup of mobile and internet links. If some ship anchor is scratching the undersea cable somehow, it might go fall back over satellite, for example. You have the branch offices, internet access, you have transportation, also the logistics, depending heavily on satellites. You know these shipping containers, and where things from China get to Europe and vice versa. These are tracked by satellites and normally speaking also X-25. So yeah, you see there are plenty of opportunities. Military, yeah, we will look at the frequency list for military satellites later on. I make a very cool detection of a name which might be familiar to all. Then news and weather forecast, but also weather forecast. I will come to that later. You can do things as well with older American forecast satellites. You have video telephony, geology, astronomics. A lot of branches might be involved in or depend on satellite technology. A bit more precise, not going into detail, just to show you, yes, GPS everybody knows, Galileo probably also everybody knows, GLONASS, that's the Russian GPS system, then you have Compass, this is the Chinese GPS system, and then you have IRNSS, this is the Indian GPS system. So you have several things which do exactly or more or less the same. I will need to investigate in that later on probably as well. The Iridium and Inmarsat, as we can see later on as well, they were broken last year at the CCC, if I remember correctly, from German guys. So yeah, there might be opportunities for everybody. Talking about space debris. Yes, we have a lot of things traveling around the Earth. This is just a visualization about 22,000 objects. Speaking about the diameter from 10 to 10 centimeters upwards. If you go a bit more in detail, then you don't see the Earth anymore. Luckily, some university in Switzerland, Lausanne, did develop a cleaning satellite. I got a news notice 2 days ago that some satellite is able to catch this shit in the orbit somehow and bring it down into the atmosphere where it just got lightened up and it gets destroyed. But this might be a real problem if you look what it might have as an impact in spacecrafts from the American, which are no longer in use. But this is a front window, and these are just dust particles. Imagine what might come if you take a baseball or something like that. It's even bigger. Yeah, good. Speaking about tracking, this is a very cool tool, almost not visible, as I must admit. It's gPredict, where you can update the database with the TLE data, where the satellite is all the time. You can have a location, this is Bern where I live, and then you have the horizon, north-south, you see the line the satellite makes through the sky, and you have also the footprint information when it comes into your range, and then you can have an interaction with it, more or less long time. Especially if they are low Earth orbit, you get 6 to 7 minutes, and that's not much for getting something really useful. Yes, there are also other programs for Windows, Orbitron, or even Predict for Linux. You can even go into the internet and having lists of it, Excel sheets, whatever you can think of. There are more references in the annex for those who are interested in this. Then talking about communication, yeah, these are the communication bands. Also here I will not go too deep into detail, just to see that it might cover from 300 megahertz, even lower, up to 75 gigahertz. And this range is very difficult to receive, to send on it and everything else. So I will stick to this kind of frequencies for the moment, because everything else is just a bit too cost intensive. Yeah, you see also Earth station frequencies. You have also different up and downlink bands in gigahertz here. This is just broadcasting. These dishes are for DVB, and the DVB is using gigahertz ranges of frequencies, and radio transmissions are generally speaking in the megahertz range. So you need special equipment for either job you want to do. Good. Yeah, this is almost not visible, but this is just information about what kind of conditions you have for ham radios. Also, it gives you information of if you have solar flares or geomagnetic changes which might influence your radio transmissions. If the object is not geostationary, then it will move fast, as we saw before. And you have, as I said, 5 to 10 or 15 to 20 minutes for communicating with the satellite. And then you need to wait up to 19 hours until the satellite is over the same location again. So I'm planning to perhaps use the Arduino board for making some antenna following objects device, which I just can put the antenna on it and then it will move the antenna like I need it for following the satellite. It's more easy than standing somewhere in the field with the manual antenna and pointing against the sky somehow. This double shift correction, I already mentioned it, and yes, the space weather influence, this is also to be respected, otherwise you won't get very poor results in capturing any communication. Good, talking quickly about the equipment. As I said, for every piece I have a special slide in the annex, and just to give you an impression, if I just listen to ham radio from satellites, you stand on a hill somehow like this, and then you follow. You need to correct the Doppler shift with this hand, then you have to the earphones probably so that nobody's listening, and then you turn it like this for getting the best reception, and you need to follow it as well. And you have how many minutes time? This might be very, very difficult, and people tend to look you very strange. I thought it would be a good idea if I made a Swisscom t-shirt. That's a telephone company provider in Switzerland, so I'm not so looking suspicious somehow. Good. This receiver is a very good one because it has no breaks in the frequency ranges, so you theoretically also can listen to other stuff. Beside the fact that in Switzerland generally authorities communicate in an encrypted way, but yeah, I'm still waiting for some results to come, and I'm keep on going with that, of course. Yeah. So for software, I use GQRX. That's a software-defined radio. This time with a FunCube dongle. You can buy this for about 180 bucks in the internet. Is about up to 1.7 gigahertz frequency range covering, and you can just have a spectrum analysis as well. And this is a tracking beacon signal which I captured very weak on some special frequency I could not yet really associate to a satellite, but might be something interesting. And if you look at audio transmissions, then it looks like this. And you also have some record button below, which is also very, very interesting. This is for a Hama Nano. This is a DVB-T adapter. And this is really a small piece for USB with a round antenna. And you can use that up to 800 megahertz. And it also has a SDR, software-defined radio functionality in it. So you can scan with it as well. This is very helpful sometimes. As I spoken before, weather satellites. Yes, you have a frequency range where you have wave files which are transmitted, an audio file which is transmitted by radio waves, and you can record that, wipe the noise in front and at the end off, and then you feed it just to a decoder, and you get these nice satellite images directly from the satellite. So if you don't trust your weather forecast, there are other possibilities to do that. I must admit, mine looks not so nice colored. I just got some crappy, distorted black and white ones, but working on it. Good. Satellite hackers, yeah, as you probably got already from several occasions, there are a lot of people already spoke about satellites, also FX, but he didn't publish the slides. That's why I thought I would make a public presentation based on public sources, so we can publish it afterwards and people can join the topic. As FX also mentioned, yes, DVB-SYN is one of the possibilities where people get involved into satellite hacking. I'm not that kind of guy, so if anybody is really into DVB, you're happily welcome to join this kind of research. I'm more a bit ham radio orientated. Yeah, this is a very interesting scene, I must admit. Good. Speaking quickly about digital video broadcasting, as I said, there is a terrestrial. This is just a normal Swiss TV channels, for example. Here you can receive by DVB-T. Then you have the DVB-S satellite standard, or S2 now. You have the cable standard, of course, and you also have some newer standards like handheld and also handheld over satellite. I must investigate in these ones as well. Just to, if you want to look something up, there is the standards which are published. It's very useful to get a concept about DVB protocol and communication, but as I said, not yet there. But you have certainly heard about the DVB drone prawn from Afghanistan. The Predator drones, they are capable of making video streams. And occasionally, they also have Hellfire rockets to shoot against opponents they detect. And with that nifty little tool called SkyGrabber, you can buy it for $30. And the right equipment, you can link into their feeds and you can get that. And I remember 2 days ago read in the newspaper an interview with some higher ranking military official from America, and they told, yeah, we have still that Predator drone problem with the DVB streams, but at least 1/3 is at the moment encrypted. I was like, okay. Read a sentence more, and there it was stated, for the rest we need until the end of 2014. So you have 2 years left for trying this. Feel free. Good. Ham radio. Yes. I must talk with the ham radio guys which one is the right definition, because if I researched where this ham originally came from, there are several versions of it. One version I found was the three radio pioneers, Hertz, Armstrong, Marconi, and the other was of the GM Dodge telegraph instructor manual, a poor operator. I won't say they're poor because they know a lot more about electrotechnic and wave signaling than I do. So I must bow before masters, really. The amateur radio license is regulated on a governmental level. It's the BAKOM, that's Bundesamt für Kommunikation in Switzerland. You get a registered call sign when you succeed in the exam. There is an introductory exam and an advanced exam. It's about 3 million ham operators worldwide. And if you want to know more about this topic, go to the Hash Center right at the end where the food is presented. They have a stand there. You can inform yourself and get a hands-on also onto ham radio. Yes, this is hardly seeable, I can understand that, but it's just showing also you have plenty of frequency ranges which are used also for amateur radio frequencies. It's just interesting also zapping through and listen to people talking from continent to continent and things like that. It's very interesting. More interesting, I found lists like this one. And who spotted first? Did you read the name here? Skynet. Does ring a bell? You know what is called Skynet? That's the British Space Defense Program. Yeah, I was a bit scared, but hopefully I have some time until next year to investigate that, where this comes from, and if the possibility is there that they will just nuke us out or something. Just remembered me for Terminator a bit too much. But you find these lists on Satellitenwelt.de, very interesting. You can zap to the frequencies and get a hands-on. Yes, hackers also do satellite projects. There is some Moorsat project from Austrian guys which do some nanosatellite, very small, with art somehow. I didn't get the concept fully. More interesting is the Hackerspace Global Grid. You probably heard of that one already. It's a fallback infrastructure and censorship avoidance where hackers will put satellites into orbit until, I don't remember the date, and providing a fallback infrastructure if the normal digital world will fall. And for everybody into Arduino, yes, there is a guy which already built a satellite tracker with the Arduino board, so this might be interesting for all the Arduino guys as well. Okay, then I got a bit into press and I read a bit about what they state about satellites and security. And yeah, especially the US are very paranoid for satellite hacking, especially that they had already some cases related to that. Just shows that the topic is somewhat a bit hot. Good. Talking about the about 10 threats I identified or can imagine what's possible to do. One is the tracking, as we saw. This is very easy. Everybody can do that. You download the software, you get the information update, and then see when, where, which satellite is available. Listening, this is a bit harder. You need some equipment. By the way, everything which is standing here is about 1,000 Swiss francs. So even for a student might be feasible. And of course, these kind of antennas you can build yourself. I was just too lazy. You need the right frequencies, and especially down or uplink if you want to listen to either communication. And probably you need to have the right location. Sometimes there are satellites which just turning around the pole and not coming down in direction of equator, so you probably need to travel more north to get a good receiving. Interacting, this is a bit more difficult because if you want to send something to a satellite, you need a license. Okay, I'm that kind of guy which doesn't bother about license first. Then he makes some buy-ins from another country and you get the stuff and you go online and then so 2 hours, no, not even 2 hours. It was half an hour to an hour later, some strange vehicle was driving through around the houses there with antennas on the top, and I was like, oh no, I will unplug that quickly. And I talked with some ham radio guys, and they even have a detection system in Switzerland where they can detect frequencies or sending devices very precise and very fast, and I fell to that one. So first I will now make legally the license, and then we will send a lot. The using, yes, of course, you can use a bird if you can take it over. You also can take over a TT&C center if you can achieve that, what some Chinese did in Swedish TT&C or Norway TT&C center, and then he got full access to some satellites. And yes, you can use the payloads, speaking of making pictures, transmit something, whatever you can think of. No, I'm not yet there, but that would be the end goal. Scanning attacking, yes, that is a proof of concept already done by Leonardo. It is possible scanning over satellite links. You even can do denial of service attacks, and you can spoof IP addresses. So this might be useful for fundamentalist groups as well. Just an idea. His talk was about scanning the NSA without tracing. Yeah. And if we are just remembering that the lifespan of satellites can be up to 20 years, yes, there are old technologies used, X25, OXDeadbeef, Marco Ivaldi, and some other tool which is cool. And of course, GRE you find quite often in satellite links. This might be very helpful to have the EOPass suite and the GRE extension from Phenolith, so you can really play with that kind of tunneling. Good. Jamming, yes, I forgot my jammer at home. Yes, you can jam the signal, but of course you need to know the frequencies, you need to be close to the sending device, and you need a certain power of overlapping the signal, but theoretically this is possible, and this is a threat which might happen. I do not know if it's ever happened, but it is possible. Even worse is the mispositioning. that you have a possibility for command injection or command replay. If you look at the uplinks, which control the satellite, making corrections in the orbit and things, yes, this would be very interesting as well. And now, yeah, the grilling. This is very, very interesting. Satellites tend to have energy problems. Normally, if I track a satellite, I have a look, yes, okay, he's here in 3 minutes, and then I have 6 minutes time. That's enough for Googling the frequencies, then you have the frequencies, and then you have a remark, semi-operational. A semi-operational can mean that it's just capable to send something if it's on the sunny side, because the battery is weak and the solar panels need to be in the sun, that it's enough power there to send something. So engineers, especially satellite engineers, tended to deploy more solar panels than needed. And under certain conditions, there might be a possibility if you fold all the solar panels on the sunny side at the same time, it gets an overcharge and it just nukes it. That might be the consequence. And even worse, collisioning is a possibility there to let collide satellites. Short answer, yes. Long answer, yes, and it already happened several times. It was discovered at 1978 already from a guy named Kessler, and this is a ablation cascade, Kessler syndrome, whatever you call it like. And this means you can take 3 random satellites in the orbit, let them collide, and the debris resulting from it will destroy all the others. And I hope this talk will not be downloaded to Iran or North Korea or something else. Just there might be somebody pushing a button and throw us back to Stone Age. 8 known high-speed collisions already happened. So the US did some anti-satellite missile tests where they fired a missile from a submarine into orbit, and it hit an old spy satellite they would not talk about, and they hit it and it generated some debris and was gone. Then a Ceres satellite collided with space debris. There was a satellite collision in 2006, and also the satellite have capabilities for shooting satellites out of orbit. So this might be a thing to think about also if you rely too heavily on satellite technology. Good. Now, just it happens. It already happened a lot. Before everything else, there was, in the 1980s already, people listening to radio satellite signals. They tried to decode the signals because often it's just an audio code which is used to transmit some secret message or something, and they were quite successful by the time. In 1990s, it was a bit before my time, I got involved really into the hacking thing. There was the freeloaders called. They shared some prawn and everything else, and it was possible to do free phone calls over satellites for quite some time as well. Then what I was involved as well, pay TV decoding, everybody did that, no, before. 1990s was actual, yeah. And then there were some cases which were more interesting. In 2002, Falun Gong, this is a religious group from China, which is banned from China. They achieved to broadcast a banner for marketing reasons on China Central TV on all channels for about 10 minutes. Then Intelsat had a problem with the Liberation Tigers of Tamil Eelam, and the case I was referring before was the Landsat Terra IM-1 was hacked over a Norway TTNC. So somebody broke into the TTNC and got the hands on the controls which were feeding up to the satellite. And it is rumored that it was a Chinese guy, but you won't have any proofs. In 2009, it was very interesting because there were a lot of Brazilian hackers on FLTSat 8, and they're just talking about soccer. soccer games. I was really, and the Predator drones, yes, of course, and some other things. Probably this list is not complete because there are probably more things happening, but just not getting it into the press. But yeah, my goal is to take over one, but I don't know if it's really an achievement worth of it at the end. Good. Yes, we need to talk quickly about politics, as US got some problems nowadays. They did stop the shuttle usage because of costs and accidents in 2011, and now they get logistics over the SpaceX Dragon, was talked on last week about, and this is just a US private organization. Probably the Americans can handle that. What was more interesting that they're also using Soyuz spacecraft from Russia. Isn't that some interest conflict somehow? Well, we gave our military spy satellites to some Russian guys, which put it into the orbit. I don't know. But yeah, NASA plans to be back in space. They want to have a space launch system in 2017 and even planning for a permanent moon base by 2024. This might be also very interesting. So more radio signals will travel around Earth and you will get known probably more things. Also, China plans an own space station, and yeah, this might be interesting as well, looking what the Chinese are doing in the space. Good. My personal outlook, as I said, I'm not really long following this track yet, but I'm not alone covering this topic, so it's a very highly complex technical field. You have merged technologies, you have physics, you have electromagnetics, you have geomagnetics, you have radio transmissions. It's very challenging. I do not have yet so much proof of concepts, but for 2013 hash days I will have, for sure, I promise that. And I'm preparing for the Heim radio license, and if you want to join, feel free to contact me, especially somebody with DVB experience in a deep level on protocols. So there is some time left. This was a rush through, I'm sorry for that, but we have still some time left for question answer. Thank you.